Tutorial Chapter 3 Ionic Equilibrium. Number 1. Define a buffer solution and give one example of buffer system. If you want to answer these questions, so give the meaning of buffer solution, a mixture of a weak acid and its conjugate base, or a weak base and its conjugate acid, which has an ability to resist pH change when a small quantity of acid or base is added to it. Example: acetic acid and sodium acetate. This is the weak acid or conjugate base, and this is the hydrofluoric acid and sodium fluoride. This is also example of weak acid and conjugate base. And for ammonia and ammonium chloride, hydrazine and hydrazinium chloride are weak base and conjugate acid. Number 2. Provide a differences with an example between acidic buffer and the basic buffer. And for these questions, if you give the difference between acidic and basic for buffer, please write in table, so it's easy for us to look the difference between acidic buffer and basic buffer. So for acidic buffer, contain a mixture of a weak acid and salt. Salt is a conjugate base, salt of weak acid. And for basic buffer, contain a mixture of a weak base and salt of weak base, known as conjugate acid. pH value is lower than 7 for acidic buffer. Example: acetic acid and sodium acetate. For basic buffer, pH value is greater than 7. Example: ammonia, ammonium hydroxide, and ammonium chloride. A buffer solution is prepared by dissolving 3.6 grams of sodium acetate and some amount of acetic acid in 1 liter water. Determine the mass of acetic acid that should be used to prepare a buffer solution of pH equal to 4.25, given Ka of acetic acid is 1.8 exponential negative 5, and this is the relative atomic mass. So if you answer for tutorial number 3, first find the mole of sodium acetate is equal to the mass divided by relative molecular mass of sodium acetate, which is 82 grams per mole. And you get the mole is equal to 0.0439 mole. If you identify the concentrations, so in bracket here is the concentration, must be in mole per liter or mole per cubic decimeter. So the volume here is the 1 liter, and mole divided by volume, and you get a 0.0439 molar. And because the solution is a weak acid and the salt is the conjugate base, so use the Henderson-Hasselbalch equation for the pH is equal to the pKa plus log concentration of salt or conjugate base divided by the concentration of weak acid. And then they give you this one is 4.25 the pH. and here is the pH 4.25, and you need to find the concentration of weak acid of acetic acid. And you shift log or anti-log the negative 0.49, or actually is negative 0.495, and you get the concentration is equal to the 0.137 molar. And convert the concentration to mole, meaning that mole is equal to the molarity times multiplied by volume. The volume must be in liter, and you get the 0.137 mole. And the question asks you to find the mass of acetic acid, and then the RMM for acetic acid is equal to the 60 gram per mole, and to find the mass is equal to mole times RMM, and you get the answer 8.22 gram of acetic acid. Number 4. A buffer consists of 0.4 molar of acetic acid and 0.2 molar sodium acetate. Determine the pH of the buffer solution. So this is the acidic buffer, and they give you the concentration of salt, meaning that the concentration of conjugate base is equal to 0.2 molar. So this is the salt, and for the concentration of acid is 0.4, and use the Henderson-Hasselbalch equation for pH is equal to negative log Ka. So this is the pKa plus log the concentration of salt, concentration of conjugate base divided by concentration of acid, and you get the answer 4.44 for the pH. Number 5. Determine the pH of a buffer solution which contains 0.9 mole of sodium benzoate and 1.2 mole of benzoic acid in a 1 cubic decimeter solution. So first, you find the concentration of salt. So this one, they give you 0.9 mole. So the 0.9 mole you divide by the volume to get the molarity. And this is the benzoic acid. For the concentration is equal to the 1.2 mole divided by volume, and you get the 1.2 mole per cubic decimeter. This is the concentration of weak acid, and you know this is the buffer of acidic, meaning that the acidic buffer. So you need to find the Ka because the question given the Kb. And to find the Ka, so Kw here is equal to the 1 exponential negative 14 is equal to the Ka times Kb. So you get the Ka here is the 6.667 exponential negative 5. And use the Henderson-Hasselbalch equation for pH. And then you get the pH is equal to the 4.05. Number 6. A solution of sodium hypochlorite was prepared at pH 10.3. Calculate the concentration of the salt formed. Given Ka for hypochlorous acid is equal to 3.0 exponential negative 8. First, get the chemical equation for the sodium hypochlorite, and this is the sodium ion and hypochlorite ion. This is the hydrolysis of salt, and the hypochlorite ion here react with the water and produce hypochlorous acid and hydroxide ion. So the hydroxide ion here, meaning that we need to find the Kb. So given Ka here, and you need to find the Kb. Use the formula Kw divided by Ka, and you get the 3.3 exponential negative 7 for Kb. And for the POH is equal to the 14 minus 10.3, and you get the 3.7. To find the concentration of hydroxide ion here, so you need to use the formula and to log negative 3.7, and you get here this is the molarity for the hydroxide ion. So this is equal to the X. If you use the ICE, initial change equilibrium, so this question, they don't give you the initial, so you just assume as a symbol A here, and we know for the initial, its product is 0, only for the reactants. So water here is not available, so leave a 0 here. And for the change is a negative X because you look at the coefficient in front, the hypochlorite ion is 1 actually. So meaning that you minus with X. You minus 1 X because this is the change. So we know when change, it will reduce here because go to the reactions for the reactant. And for the product will gain. That's why the X here is the positive X because the coefficient here is also 1. And you plus X for the product. And same goes to the hydroxide ion. It is 1 here coefficient, so that's why plus X. Meaning that plus 1X. And for the equilibrium, meaning that I initial you plus with the change. So A minus X here, but we assume the X is the value, small value. So that's why we just consider as A. And this is the product for X. And for the hydroxide ion also X. And we know from the calculation the X is 2 exponential negative 4. And to find the A, use the formula this for Kb. And you get the A is equal to the 0.12 molar. Question number 7. So first, write the chemical equation for the benzoic acid and ICE table, and use the formula for the Ka. Concentration of the product divided by concentration of reactant, and you get the value of X. And same here for the hydrogen ion or hydronium ion, and use the formula of percent ionizations, and this is the value for X divided by the initial 0.005, and you get the percentage is 11.32%.